If you're putting 40,000 volts, I don't know. Go! Oh, let's go!
Broke it. Damn. Oh,
What?
Oh my god, that's plasma. Turn it on. Plasma. Did you know that you can make an electric propulsion system at home? Seriously, it's simple enough for even bored college students to do it. But what we didn't know was that it was going to be so much fun. Mark Zuckerberg once said,
"Ideas don't come out fully formed. They only become clear as you work on them. You just have to get started."
So that's what we did, and we hopped right into a Zoom call. Alright, so we know electricity and magnets are cousins. If you didn't know that, think of the 4 fundamental forces and ask yourself why one of them is called the electromagnetic force. Electric propulsion comes down to using electromagnetic fields to accelerate a mass, therefore making thrust. And what's the motto? In thrust we trust. An MPD thruster is simple. You know when electricity is so excited that it arcs? An MPD thruster uses that electrical arc to ionize the gas in between to create ionic wind, which then creates thrust. Hence its name, ion thruster. During our research, we found this video by Intexa, which was great help. I've linked his video as a card here. We decided we'd use nickel for our positive side and aluminum for our negative side. After our research, we knew we needed lots of voltage, so we got the sketchy one from Amazon. 3 volts to 400 kilovolts, naturally we were suspicious. Then we went out to Home Depot. Micro Center, please open a location in San Diego. Okay, so we got some of the stuff. The transformer's already here, as you guys know. But we couldn't find the nickel strip, but we did find this piece of wood that was 70% off. Okay, so we got the stuff here now. Jackson and I finished these 2 Sprite cans. So we got most of the materials. We just need to start hooking them up. What are we missing? The things we were missing was these nickel strips, but these are too thin. We may have to get thicker ones.
We can solder them together.
You think we could solder them together?
Yeah, the metal one there. Yeah,
okay.
Tap.
We could try it. We could try it. Turns out we didn't need to do this, and they were actually thick enough, so we're good.
1.5.
These are all 10-inch strips. Or, sorry, 10 centimeters.
What? 10 inches?
10 inches. After that, Jax made a 3D model that would hold the nickel strip we'd use for the positive side. Our printer got messed up somehow, so we'll print it tomorrow. But right now, we're just going to test out the concept. So we'll see if what this guy did, if what this guy's doing can be replicated. Oh! 400 kV! Discharge. This was good. We can actually tase someone and probably stop their heart. But it clearly wasn't enough. What we realized is that AA batteries don't produce enough consistent current. Here's a basic electronics fact. Power equals current times voltage. That meant we needed to bring out the big guns, the lithium polymer battery, specifically the 1S kind, since our transformer input only took 3 to 6 volts. Okay, it's Saturday. We made a little bit of progress. We had the goat print some stuff.
What up?
We also used these scissors to cut the nickel. The teeth on the nickel are so that the electrons are focused and would jump to the other side. Everything was pretty much done just to test if it'd work. We tried using the AA batteries again, but everything else was falling into place. Stay tuned for the lipo batteries later. Well, we got the electrical fire extinguisher, you know. Take care of business. Okay, wait, back up a little bit more. All right, ready to go. And finally, it pushed a piece of paper.
One.
Oh! Now we have to worry about efficiency. Clearly, it was not outputting enough ion wind. And here's the results with the lipo battery. Do it again. Sorry, that was just us messing with the taser again. Here's the real video. That is a lot more. That's a lot more than the battery.
It is wrong.
If you enjoyed the video, consider liking and leaving a comment. If you like this sort of stuff, consider subscribing and turning on the notifications. You can find way more ways to reach me in the description below, especially my live streaming and schedule. And as always, stay curious.